So the plasma cutters arrived. I will do a video about that when I set it up, but I'm not actually going to do it at the moment because I haven't got the piping to configure it, because I'm going to put the piping up around the ceiling and put compressor upstairs. But I mean, I could try it, but I've got other stuff to do. So I've just finished the final cap and run on the end cap, and I've done one of the very tedious grinding on the next battery pod so I can get that end on. So I'm just turning this piece down to 100mm and facing it off. Got quite a bit of stick out here, which is much more than I would normally like, but there's not much I can do about it. Well, just before I took it off, I've just put the tiniest little blip in the middle there just to mark the centre. I'm going to now try and mark this up as accurately as I can. I don't know if this is the right way to do this, or whether I should be drilling it on the mill maybe. But I've got it at 108 RPM. It's a little bit worrying. If it's at 108, it doesn't go any quicker. Does seem to be working. Okay, so I've got the boring bar on, and these are M20, these blue globe connectors, and you can see, look, there's hardly anything of it actually going down, so I don't really need to bore down very far. I mean, that's 5.69, that says 7mm, so 18.03, that's exactly what the DRO says, so I'm going for 18.5. Right, now I went down, I've gone down about 25mm, which is way more than I needed to go, but just because it was cutting easily. Now I'm going to power tap this, which is always slightly unnerving. In coolant, I don't know why the coolant wasn't coming out. Honestly, this pump, this is driving me up the wall. It's this could be the last straw for this pump, I'm telling you. I'm going to take this out because I don't want to risk breaking the tap. That should have come out, but it didn't. When I turned into reverse, it didn't come out. So I'm going to wind it out manually. It seems to have got stuck there for some reason. Some funny little... Now it's free. Well, perhaps the lack of lubricant. I pressed the button, it didn't come on. Stupid pump. Again. It's this thing that's the problem. This. It kind of goes, this thing rides up. This could be the last straw. Anyway, right, what was I doing? Right, so I think I got enough thread on there. Right, so there it is, there's the blue globe in place. Everything's looking good, except what I did, I've made a mistake, funnily enough. When I marked these holes, I marked them all really carefully and they were all in the right place. But when I offered it up into the lathe, I was so worried about getting the forge all lined up and correct. So I didn't even look at which one of these four I lined it on with, and I had a 50-50 chance and I got the wrong 50. So that is in the wrong place. Now, that will only matter if I do the recess option, which I'll show you on the CAD. Okay, so here's the blue globe penetrator. It's fairly straightforward, except this idea was to have these parts recessed in, so you can see if we look at it like that, you can see they're basically recessed. Yeah, the idea being that I can get an M10 socket in there to tighten them up. But the problem is, if I show you this, yeah, where did I do it? There, I think. That, yeah. Yeah, okay, so here's an example of how it would fit. There's a couple of problems here that I can see. First of all, if I look at the analysis again on this side, you can see right here where I'm going to be welding these together, this point here and this point here. It's very close to this here, and this face needs to be flat to seat the O-ring. So I just think that if I weld here, it's going to distort. Stainless steel distorts really easily. So I'm not going to do this. I've changed my mind on it. But the other thing which I think is, having looked at this drawing again, now it does fit, yes, but I don't think I've been very generous on the length of this. I just feel as if this is about 9mm from there to there, and I think I'd like it to be just a little bit more, just to be on the safe side. So I'm going to redo the thing again at 120mm. Yeah, that's kind of a better view. The whole point of the recess is that when this is in, it'll be kind of about like that, and it'll be sticking down quite a lot into the battery pod, and I just really wanted to be able to slide the batteries easily in and out. And if it's like this, it might mean that I have to mess about unscrewing this to get them in and out. I mean, it's not the end of the world, but done the other bevel, so both ends have done. That's a real pain, that job really is. And then whilst that's been going on, my little saw is busy chomping through another piece to do that part again. So this is where I went wrong last time. I was so worried about getting the forge jaw correctly lined up and everything that I lined this up with the wrong hole. Right, this is attempt number 2. Now the trouble is here, this is now 120, so I've had to, I've gone, this drill is held very precariously in the end, but it does seem to be working. So, what can I do? I can flick it around to the other side, I suppose. Right, I had a bit of a problem with this because once I've taken this out, obviously then I've got to line it back up and I've got to get this bore concentric again. So I've had to dial it in. I've got it within about 4 to 5 thousandths, which sounds a lot, but the thing is I've got this, there's so much float on this drill I've got in here. It drops around, like you can hear it. So I think that's as near as I can get it. It's not bad, it really isn't. That's not bad. Okay, so halfway there, I've got to do the other hole. Now this is in the correct place, so I could put that counterbore thing in like I'd shown in the CAD, but I'm not going to, simply because of that possibility of it twisting with when it's welded in. Stainless steel's a devil for deforming. I've got a sort of a spare, very expensive chunk of 316 at 80mm with an off-centric hole in limit. Not sure what I'll do with that.